In example 4, we're going to derive the formula for finding the area of an oblique triangle. And we start with an oblique triangle, a triangle that does not have a right angle. We draw a perpendicular line, or an altitude, and actually let's label this A, B, C. Drop our altitude down from B to the base, which is a right angle. And this is also called the height, or H. Now what we know, you should have seen at some point before, is that the area of a triangle is 1/2 the base times the height. You may have seen this formula written as A equals 1/2 BH, or A equals 1/2 BA, A being the altitude. So what I want to do is come up with a relationship using H, and since I know once I drop that altitude I have two little right triangles, I know that the sine of C would be equal to the opposite over the hypotenuse of that little triangle, and I know this side right here is little a. So the sine of C is H over A, and so if I multiply both sides by A, I would get H equals A sine C. So if I use this formula, the area equals 1/2 the base times the height. If I call B the base of this triangle, H is the height, the area will equal 1/2 the base, which is B, times the height, which is A sine C. That's one formula. I could also use angle A, let's write inside C, and say that the sine of A is equal to H over C, using a different angle, and H would equal C times the sine of A, and so my new formula would be 1/2 A equals 1/2 the base, which is B, and the height we have this time written as C sine A. And then the third formula, if I drew the triangle a little bit differently and I drew my altitude from angle A to side A, I would come up with the third form of this formula, which is A equals 1/2 AC sine B. So you can use any of these forms of this formula. 1/2 BA is often written AB, but you can use this to find the height of the area of an oblique triangle.